JPS units will be used. The first unit pumps compressed air or pure oxygen, while the second unit pumps an ignitable gas capable of reacting with oxygen. The combustion reaction, hundreds of meters underground, will produce an immense amount of heat and massive volume of superheated carbon dioxide gas. Methane, ethane, propane or butane, for instance, are ideal for combustion reaction with oxygen. Before pumping the two elements down the two pipes, an electronic igniter with a built-in timing mechanism is dropped to the bottom of the well. Then we start pumping oxygen via one JPS unit and methane via second unit. Half an hour after dropping the igniter, its timer will initiate a combustion reaction between methane and oxygen. When the methane starts burning, it will produce an immense amount of heat and a huge volume of superheated carbon dioxide gas. The immense heat will cause the oil and oil rocks to burn and be converted into runny liquid oil or sludge. As long as we continue to pump compressed air or pure oxygen, the surplus oxygen will ensure the continuation of the fiery combustion reaction of oil. The electronic igniter consists of a timer and two chemicals placed in two separate jars, similar to the thialume stick or the glow stick. The timing mechanism produces a shock and causes the two glass jars to break. The subsequent violent reaction between the two chemicals will cause them to burn and produce high temperature and heat. The burning of the chemical mixture will ignite the oil rocks, and the pumped compressed air or pure oxygen will keep oil to burn. More heat is produced and the pressure at the bottom of the well will rise dramatically, converting more of oil rocks to runny liquid oil. The combustion reaction will produce a huge volume of superheated carbon dioxide gas, which will settle on top of the runny liquid oil and cause a dramatic rise in the well's internal pressure. Since the oxygen pipe is full of either air or oxygen, therefore the fire cannot take place inside the oxygen pipe. Therefore the fire will only take place down the oil reservoir. Abandoned and seemingly depleted oil wells contain enormous amount of oil, either as thick oil sludge or as solid rocks. These wells have been abandoned simply because after pumping a great percentage of their content for several years, their internal pressure had dropped below the critical pressure necessary to push the precious liquid up to the surface. Their internal pressure must rise dramatically again to bring them back to life and get their oil out. They must repossess that great force which made them gush oil when they were first brought online. Hydrogen cannot be used because water will be a byproduct of the reaction when burned with oxygen. Since the primary purpose of having a controlled and continuous fire raging at the bottom of the reservoir is to increase the pressure at the bottom of the well, having water as a byproduct will not achieve that goal. Using two JPS units does not necessarily mean we can only pump pure oxygen via one unit and an ignitable gas, methane for instance, via the second unit. The possibilities are endless. For example, oxygen can be pumped via one unit and a combustible liquid via a second unit. Alternatively, a mixture of two or even three gases can be also pumped via the second unit. A mixture of ignitable gas and combustible liquid may also be used. In short, the best possibility and the best combinations of gases and liquids may be used, which will give us a huge amount of heat and immense volume of carbon dioxide gas at low cost. We may choose any cost-effective and efficient mixture to produce immense heat, generate a huge volume of superheated carbon dioxide, increase the internal pressure of the reservoir, and burn the oil and convert it into runny liquid oil. To reduce production cost, the ratio of compressed air or oxygen to the ignitable gas or liquid can be 3:1 or even as high as 10:1. The oversupply of oxygen will ensure the continuation of the raging fire. The economic benefits of using an overabundance of oxygen is quite clear. In essence, we are burning cost-free abandoned oil at the bottom of the oil well with surplus oxygen to produce immense heat instead of paying for purchasing an ignitable gas, such as methane, and transporting it to the location. When using this method, initially the volume of extracted oil is small, but as the pressure deep down the well starts increasing, and depending on the size of the reservoir, the amount of recovered oil will increase dramatically. For every barrel of ignitable gas used, 10 barrels of oil can be produced. Oil experts and engineers assume that abandoned oil fields still contain half of the oil they had at production peak when they were first started producing the precious liquid. From some abandoned or seemingly depleted oil wells, it took mankind a century to pump out half of their content, yet they still contain the other half, languishing at the bottom waiting to be extracted. By using this JPS unit and this extraction method, oil can still be produced from such wells for another century at full capacity. Oil in these abandoned wells is worth billions of dollars. The economic impact and value of this method can never be exaggerated. For every barrel of ignitable gas and pure oxygen used in this process, we can conservatively recover 5 barrels of oil. Given the relatively small cost of using barrels of gas and pure oxygen to the high value of producing 5 barrels of oil, the conclusion is inescapable. For every dollar spent in production cost, $100 in profit is generated. Multinational oil corporations can expect $100 billion in revenue for every $1 billion spent in operation. So what are the industrial applicability? The use of this invention in abandoned and semi-dried oil wells will have a huge financial impact and will result in the recovery of enormous amount of otherwise wasted barrels of oil. Abandoned wells will become active again by releasing their precious unexpected oil. Given the fact that world oil production peak has been passed several years ago, multinational oil corporations are scrambling to find new untapped oil wells in far corners of the world to quench the thirst of our industrial world. They are drilling in extremely difficult locations, sometimes 1,500 meters below sea level, such as in the Gulf of Mexico. In desperation, they are extracting oil from tar sand, a difficult, inefficient, and costly method. For each calorie they are spending, they are getting only 2 calories. This invention and its extremely simple but efficient operation method will make oil extraction from abandoned or seemingly depleted oil wells exceptionally simple and profitable. It requires only a small investment in equipment and low running costs, which is more than offset by the huge expected profit. One energy estimate stipulates that the amount of oil still left in abandoned oil fields around the world is greater than the oil in running oil fields. Thus, this invention will have the potential to help increase world oil reserves by a great percentage.